Knowing about the concept of dynamic ARP inspection is one thing, but is yet another to actually implement it, which, my friend, is exactly what we are going to do in this nugget. Let's begin. It's really important to make sure that DHCP snooping is activated and on and working. Let's do a quick check just to validate that DHCP snooping is working by looking at the binding or the database for DHCP snooping. Just as a good start to help us verify we have something to work with as far as validation. And sure enough, we've got this MAC address, B827, IP address 1023.0.2. That's on port 0/2. That is our Kali box. That's the attacker box that's physically connected to that port. And this MAC address of 000C with the IP address of 10.123.0.3, that is a Windows computer that's connected off of the trunk that is on gig 0/1. So that's the context for those two entries in our DHCP snooping binding that we're going to be using as part of Dynamic ARP Inspection. Now, to configure Dynamic ARP Inspection in global configuration mode, the command is IP ARP Inspection, the keyword VLAN, and then the VLAN that you want to apply it to. And boom! At that moment, all the ports in that VLAN on this switch are now untrusted from the perspective of Dynamic ARP Inspection, meaning the ARP police are now engaged on all ARP traffic trying to enter any of those ports. I always believe in verifying once we put in a command in, so let's do a quick verification with show IP ARP inspection for VLAN 123. So this says that we're currently enabled as far as configuration wise for dynamic ARP inspection, and it's currently active. Now we have not configured any ARP access control list yet, but we will. And so when we do create an ARP access control list for manually identifying the IP addresses and the MAC addresses, the access control list itself, the name, will show up right here. Now, port gig 0/1 is a trunk port. And although we do have a single dynamically learned host out there, it's quite possible that we might have lots of other switches and DHCP clients. It's a likely case that we're going to have that port be a trusted port from the perspective of dynamic ARP inspection. So to teleport that it is trusted, we'd go to that interface and use the command IP ARP inspection trust. And that simply turns off the ARP police for any traffic that's entering that port. Now in the case of gig 0/2, that's where our user is, or in this case the attacker is there. So let's go into that port, and we don't have to set it up as untrusted because it's untrusted by default, but we can tweak, for example, the packets per second. So if we don't want to do 15 packets per second, which is the default rate limiting for ARP-related traffic on an untrusted port, we can go ahead and change that to something else. So in our case, in interface configuration mode, we're going to use the command IP ARP inspection limit rate 10, meaning 10 packets per second. And we might have a situation where we need to increase it. Maybe in the normal course of business, 10 packets per second of ARP-related traffic is not enough for whatever reason. So the key here is we may want to do some baselines to find out, okay, what is the typical or average or needed packets per second for ARP traffic? And then we can move it up if needed. And it won't take long, by the way, if your value is too low, because the users will be complaining that their port's shut down. They can't get access to the network if they violate it, because the violation of the rate limiting is going to put the port in an error-disabled state. Now on the Kali box, just to validate this, let's go verify the IP address and the MAC address just to make darn sure we're looking at the same information. So here's the MAC address, and that does reflect what the switch saw. If we go back to the switch saw this MAC address right here of B827EB, etc. And on the Kali box, that does match. And the IP address that our Kali box is currently using is 10.123.0.2, and it is a DHCP client. Otherwise, its entry would not be in the DHCP snooping database. Now, if you're recreating this in a lab and you want to tell your Ethernet 0 interface on a Linux box that you want it to be a DHCP client, the command you'd use is dhclient space and then the name of that interface. In this case, it's Ethernet 0, and press enter. So in this case, even though we already were a DHCP client, I just did this command for your benefit in case you want to replicate this. And again, going back to the switch just to validate that the DHCP snooping binding is correct, we can do a show IP DHCP snooping binding, and that will show us exactly what's there in that database. Now in the case of interface gig 0/3, that is a trunk port that goes up to the router. And we only have a single device out there off that trunk port, which is the router sub-interface. So what we could do, if we wanted to, we could either make that interface, gig 0/3, a trusted port, which turns off dynamic ARP inspection, or we could create an ARP access control list with the IP address and MAC address of that router, and then leave port 0/3 as a untrusted port. So this would be a great opportunity to demonstrate how to go ahead and create that ARP access control list. So let's go up to the router and let's ask the router about a few details regarding itself. Please show us, Mr. Router, interface FA0/1.123. And he says, my MAC address is this and my IP address is this. And it's those two pieces of information that we're going to put into an ARP access control list so that ARP inspection can verify the information for that router's address and his MAC address regarding ARP messages that are trying to be sent in on port 0/3. So we'll make a road trip back to our switch, and at the switch we are going to create an ARP ACL. And the syntax is ARP access-list, the name of the access list, and then press enter. In our case, we're going to name it our-ARP-ACL, but you could name it virtually anything you'd like. Next, in this access list, we need to have a permit statement that says the IP address of the router and the MAC address of the router are to be permitted. And then when the ARP police are making their checks regarding ARP messages, they can use this information as part of their checking. And the syntax for the permit statement is permit IP host, the IP address of the router, in this example, the keyword MAC, the MAC address of that router, and then a wildcard mask. Now there's more than one way to create an access list. We could have, for example, not included the wildcard mask and instead inserted the keyword host right here, which would imply this one and only MAC address. All 48 bits have to match. And either way you do it, as far as the creation, is perfectly fine. Just like there's multiple ways of creating a standard or extended access list, there's multiple options inside of an ARP access list. Of course, we'd want to verify this. And to verify, we'd use the command show ARP access-list and then the name of the access list that we want to look at. And it's going to show us the contents. So it says permit IP host. There's the IP address of our router. It used the keyword host instead of the wildcard mask at the end. And then it has the MAC address associated with that IP address. Now there's one other very important step that we have to take in order to get this ARP access control list working, and that is we need to apply it. Now the switch may have lots of VLANs that it has ARP inspection working with, so part of the syntax is IP ARP inspection filter, the name of our access control list, the keyword VLAN, and then the VLAN number that we're applying this ARP ACL to. So now, inside VLAN 123, as it's checking and verifying ARP messages and the contents of those ARP messages, it can use this ARP access control list above and beyond the DHCP Snooping database or DHCP Snooping table to confirm the validity of the information in those ARP payload messages on untrusted ports where ARP inspection is happening. So you'll notice now with the command show IP ARP inspection for VLAN 123, it's enabled, it's active, and now we have the ACL match option due to the ARP access control list that we configured that has additional information about layer 3 and layer 2 addresses. So let's have some fun with this. I'm going to turn on terminal monitor because I'm connected via a VTY session. I want the console messages to pop to the screen. Now on the Kelly box, I just want to validate I have basic connectivity, and look at this. I do not have basic connectivity. Let's do a Control C. We'll do an IF config for Ethernet 0. And look at this. I do not have an IP address. Let's go ahead and fix that. Let's do a DH client, Ethernet 0. I know we had an IP address a few moments ago. I'm not sure what happened in the background. And let's do an IF config again. There we go. Okay, so now our IP address is 10.123.0.4. That's our Kelly box. And because we learned it via DHCP, if we go back to the switch, and we use the command show IP DHCP Snooping binding, it should show up there as well. And sure enough, so there's our MAC address of the Kelly box. There's its IP address, and it indeed is on port gigabit 0/2. And I just want to validate that this Kali Linux box can ping 10.123.0.3 or some other device on the same subnet just to validate we have basic connectivity. So back at our Linux client, we'll do a ping to 10.123.0.3. Okay, that looks great. We'll do a Control C to stop that. Let's also ping our default gateway of .1. That works great. Fantastic. So that's just a sanity check. I just wanted to make sure we have basic connectivity before we start. Next, let's go ahead and launch an ARP spoofing attack. Now for the details about how to use this tool called ARP Spoof, go check out the Penetration Testing with Linux Tools course. And there's a video called ARP Man-in-the-Middle Attack in that course that'll walk you through the details and the syntax of how to set this up and how to do it. And in this video that we're currently in, our objective is to mitigate this type of an attack from being successful on our network. So I'm going to go ahead and launch this attack, or attempt to launch this attack. And if we go over to the switch while this is happening, look at the messages that are coming up. We have these Dynamic ARP Inspection, DHCP Snooping, deny messages. Because we are sending out a whole bunch of inappropriate ARP messages as we're trying to spoof. Now the attack that I'm launching here back on the Kali box, and let me go ahead and do a Control-C to stop it. And it's going to take just a moment after the Control-C and clean up its mess, try to put things back as they were, to reverse the effect of the ARP poisoning that it was currently doing before. And this was sending these ARP messages over to 10.23.0.3, saying inside of the ARP messages that the new MAC address for 10.123.0.1 is really whatever the current MAC address is for the attacker machine. So if this attack was allowed to go into the switch, now the ARP inspection stopped it, but had this attack been allowed to happen, the host at 10.123.0.3 would have a poisoned or corrupted ARP cache. It would believe that 10.123.0.1, which is its default gateway, has the layer 2 address of this. And fortunately for us, we went ahead and had Dynamic ARP Inspection, which prevented the attack from being successful. Now you'll notice it just dropped the ARP messages, and I think we should still have connectivity. So if we try a ping again, we should be able to ping 10.123.0.3. I'll do a Control-C to stop that ping. But it's successful. So we haven't lost connectivity to the network, but we were having our malicious ARP traffic dropped at the edge of the switch. Now this Kali Linux box is sitting on port gig 0/2 of the switch. And because we set the ARP inspection rate limiting to 10 packets per second, which is different than the default of 15 packets per second, if the host on that port tried to do nmap, for example, this command right here is doing a ping sweep of the entire subnet, or trying to do a ping sweep of the entire subnet, it's going to involve ARP requests for hundreds of addresses. So I'm going to go ahead and do a Control-C, because that ping sweep is not going to work. And that's because back at the switch, we exceeded the rate limiting settings. So here it says that 16 packets were seen within 25 milliseconds. So that nmap utility was just going out like a banshee, trying to do that ping sweep very, very quickly. On gig 0/2, the port is now in error-disable state, and that interface is now down. Now, one of the challenges with having this happen is that in order to get the port back up, the administrator has to go back in and do a shutdown on the interface and then a no-shut to bring it out of an error-disable state. And it's not too much work to find out, which ports are in error-disable state. We could do a show interface status space error-disabled, and they'll show us exactly which ports are currently in an error-disable state. In this case, just gig 0/2. So we'd go into interface config, type in shut, type in no shut. But on a huge network, how many times do you think this might happen? And the answer is quite a bit. And although we do want to be aware of the activity and we do want to stop it, we don't want it to have to be an administrative burden to bring up these ports. And that's why we can set up thresholds for automatically bringing ports back up. And the way we would configure this is to tell the switch, okay, based on an error-disabled state for a specific reason, if this happens, go ahead and bring the interface back up after a certain period of time. So in this example, we're using error-disable recovery cause, ARP inspection, in this case rate limiting being exceeded, and error-disable recovery interval 30 seconds. So every 30 seconds, any port that has been shut down or error-disabled due to ARP inspection will automatically be brought back up and out of error-disable. So if you want to set this to 600 seconds, or 200 seconds, or 500 seconds, it's completely up to you. And there's our little console message indicating that that interface has now been brought back up. It's no longer in error-disabled state. However, if the attacker tries to run that ping sweep again, or anything else that's going to exceed that volume of traffic, it's going to trigger it again. If we want to look at statistics regarding ARP inspection, we can use the command show IP ARP inspection statistics, tag on the keyword VLAN and the VLAN that we're interested in looking at, and it will show us the statistics regarding dynamic ARP inspection for that VLAN. So regarding ARP messages, there's been 42 that were forwarded and 24 that were dropped. During this assessment check, if you need more time, just pause during the music, take as long as you need, and then we'll review the answers together. Good luck. Number 1, PPS, packets per second, ARP violation results in what? And the answer I'm looking for here is an error-disabled port that's been brought down based on that violation. Question number 2, why would an attacker perform ARP attacks? And it's very likely that attacker wants to do a man-in-the-middle attack by doing ARP poisoning the ARP caches of other devices on that network segment. It's also a possibility that the attacker is going after a denial of service attack, but most likely it's a man-in-the-middle attack that's being pursued by the attacker. And question number 3, when would you use an ARP ACL? And the answer to that is if we have a port that is not a trusted port, which is the default behavior, but yet at the same time we don't have a dynamically learned IP address, a DHCP address on that device, then we would use the ARP ACL so that we can map the layer 3 and layer 2 information. So dynamic ARP inspection could learn about that mapping in spite of it not being in the DHCP Snooping database. Dynamic ARP inspection to help protect against ARP poisoning types of attacks. Hey, thanks for joining me in this nugget. I hope this has been informative for you, and I'd like to thank you for viewing. Occasionally, seeing things from a slightly different perspective help us to reinforce and better understand those concepts. In this nugget, I'd like to share with you a tool that we're going to use that'll help review and reinforce some of the concepts we've learned so far, as well as teach some additional concepts regarding spanning tree protocol. Let's begin. Have you ever had the experience where you've read or you've watched something and didn't just quite click the first time, and then you take a look at it again from a slightly different perspective and it's like, bonk, the light bulb goes on? Well, what I'd love to do with you is 2 things. Number 1, I want to do a brief review of a couple of concepts that we've covered so far and also introduce some new topics, including VLAN hopping and some spanning tree protocol attacks. And in order to accomplish those 2 goals, what I'd like to do is have us watch this specific nugget called Securing the Switched Data Plane, and it is from the course 640-554. As I reviewed that video, I thought, oh my gosh, there's some awesome content here that is extremely valuable, not only for certification for the current CCNA Security, but also some really good best practices for the real world as well. So it's a win-win situation. So that nugget called Securing the Switch Data Plane is from the course 640-554. It is video number 5. So here's our game plan. We'll go enjoy that video together. I would encourage you to take notes as you go through it. And then as you watch it, think about, why is this important? Why are these topics that Keith and I are going over together, why are they important for security? And what would be the ramifications or the problems that could happen if we fail to implement these security measures? As we watch and enjoy that nugget together, there will be a little bit of review as well as some new content. And again, the whole cool thing is that it's a slightly different perspective, which is going to help us to reinforce everything we're learning. And as you go through it, if you want to take advantage of some of the speed controls to perhaps speed me up a little bit or slow me down a little bit, please feel free to take use of those controls, which are available whether you're watching it on a computer or whether you're having it delivered via a mobile app. And then, my friend, after we've enjoyed going through that nugget together, and it is a lot of fun, by the way, we're going to come right back here to 210-260, where we'll do a quick review as well as an assessment, just to confirm that you and I have all of our I's dotted and T's crossed regarding the important security elements that we've learned in that nugget. I also want to take a moment and just navigate to the course. You can see it done. And the search tools are slightly different on a mobile app versus being delivered on a PC, but the concept is the same. So I'm logged in here on my computer to the CBT Nuggets website. I'm going to click on the search icon in the upper right-hand corner. I'm going to type in 640-554. It returns the CCNA Security 640-554 course. We'll simply click on that, and that'll take us to that course. And in that course, if we scroll down, our assignment is video number 5, Securing the Switched Data Plane. And all we simply do is click on it, and that will launch the video. So we'll watch that nugget, and then we'll come back to our 210-260 course for our review and assessment. So I look forward to spending some time with you in that nugget called Securing the Switched Data Plane. And then following that, I also look forward to seeing you right back here for our review and assessment regarding secure switching. Until then, I hope this has been informative for you, and I'd like to thank you for viewing. I remember a show from, I think it was the 70s or 80s, Welcome Back, Kotter. Welcome back, welcome back, welcome back. With Horshack, ooh, 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 Mr. Kotter, Mr. Kotter. Fun, fun show. In any event, welcome back to 210-260. What this nugget is, it's a review of what we learned in the homework assignment. And that homework assignment was to watch the nugget called Securing the Switched Data Plane. Now, if you have not yet watched that nugget, I would encourage you to pause the video right now and make the very next nugget that you watch that nugget that was assigned. And all the details regarding that video, where it is, how to get to it, how to watch it, are in the nugget called Secure Switching. For those of you who have watched that nugget that was assigned, you are in the absolute correct place. Let's begin. Now, when I watched that nugget in preparation for the current CCNA Security, I was reminded of a lot of the details that, we simply forget over time, including some best practices regarding switching. So here's a laundry list of several of the topics that were identified and talked about in that nugget. And one of the cool things, and what I would encourage you to do, is anytime you want more detail on some specific topic, go to the source. I've got a friend called Peter, and I worked with Peter several years ago, and he told me, Keith, I took the CCIE exam 4 times. And then the punchline was, and I've got 4 CCIEs. Peter was an amazing person. So I asked him, how do you go about studying and preparing for a CCIE? And he said, honest to goodness, he said, I go get the documentation from Cisco, I read it, I lab it up, and then when I go take the lab, it's easy. Well, it was easy for him. He's a brilliant, brilliant man. And for us mere mortals, we can also use that online documentation to dig into more of the details or to confirm our understanding using that additional resource. And the cool thing about switch security, it really doesn't matter which version of documentation you're looking at. For example, this is a 3560 configuration guide. There's a lot of different switches out there, and this is for iOS 15. And the cool thing is that most of the switch documentation regarding 12.x or 15.x is going to cover that core security information. And as new features come up and are only part of newer versions, then of course those specifics would be only in the new versions of the documentation as well. So for example, if we wanted to get more information on port security, we could do a Control F and do a search for port security, or we could look at the table of contents here on the left, scroll down, and as we scroll down, here is the configuring port-based traffic control. We could select that, and then we have port security as one of our several options in that section. So we'll click on configuring port security, and then it lays it out for us. Understanding port security, configuring port security, verifying port security, it's all right here. And I see 2 chapters up right here, we have configuring Dynamic ARP Inspection, which describes what Dynamic ARP Inspection does, how to configure it, how to verify it, and again goes into more detail regarding Dynamic ARP Inspection and its dependencies, including the DHCP Snooping database. Here's a section on spanning tree protocol, and here's a section on optional spanning tree protocol features. And included in that optional spanning tree features list are some security measures we can take. For example, there's BPDU guard. There's BPDU filtering. There's root guard. I would also consider loop guard to be a security measure. Now, loop guard specifically wasn't in our nugget, but if we wanted more detail on loop guard, we could click on it. And here's an overview of what loop guard does. And what it does is going to prevent alternate or root ports from becoming designated ports because of a failure that leads to a unidirectional link. And if you want to enable it, we'd use the command spanning-tree loop guard default in global config to turn it on. Now, a big piece of the formula for success for you and I is to have us go through the nuggets, enjoy watching them together, and then when possible, do hands-on practice, and then when curious or when you have a question, go to the documentation to dig deeper to confirm your understanding of how a protocol works, or perhaps what the syntax is for a certain feature that you'd like to use. And everything should be done in a test environment first and verified. And when we do roll it out into a production network, it should be done following the change control process that's in place for that company. And that way we're keeping everybody safe. So now it's time for the assessment. This is also the time when you might be thinking, if you didn't watch the nugget that was assigned, maybe I should have watched that nugget. It's not too late. That nugget is sitting there waiting for you. I encourage you to watch it if you haven't already, and then come back to this assessment. So a couple things about these questions. Number one, this BIA is an acronym for burned in address, the burned in layer 2 address, for example, on an Ethernet card. And regarding the 3 STP security features, if you can come up with 4 or more, that's just bonus points. So I'm going to put some music on for a moment, pause it, get as much time as you need, and then resume, and we'll review the answers together. Good luck, my friend. Boys, question number 1, what could a rogue switch send, causing it to become root? And spanning tree, as you learned back in ICD 1, is a lot like golf. The lowest score wins. So if a rogue switch sends in a superior BPDU, which is a lower bridge ID than the current root, that could cause that rogue switch to become root by sending simply a superior BPDU into the network. And for the next question, it reads, what are 3 spanning tree protocol security features? And the ones that come to mind right off the bat would be, for example, root guard, BPDU guard. I would also consider BPDU filter a security measure. Loop guard would be another one. And there were several more in that optional STP feature section in the documentation. So we are going for 3. Here's 4. That'll be good enough. So I would consider that a win for this question. Next question, how can you prevent VLAN hopping? And one of the things we can do to help prevent VLAN hopping is for the native VLAN, we're going to use a native VLAN that's not used anywhere else. So we create, for example, VLAN 70, and we make that the native VLAN on all of our 802.1q trunks. We're also going to make sure that for our access ports, we're not going to allow those ports to negotiate a trunk with whatever the heck is hanging off the other side of that port. So if it's an access port, we're going to tell it that it's an access port, and we're going to turn off negotiation so there's no possibility of the switch believing it should trunk out to an end user device. Question number 4, should trunks have a user VLAN as their native VLAN? And the answer is heck no. So if you have users on VLAN 2, 3, 4, 5, 6, 7, 8, 9, 10, we wouldn't want to use any of those as the native VLAN on our trunks. So for example, maybe we create VLAN 777, a good Vegas number, and then we use that as the native VLAN, and it's not being used, 777. We're not going to use that as a user VLAN anywhere, just for our trunk native VLAN. And again, it helps prevent a VLAN hopping attack from being possible. And last question, true or false? Computers always use their layer 2 burned in address. As I read that, burned in address, layer 2 address, a little bit redundant there, but I think you get the picture. And the answer is no, they don't, especially if it's an attacker who's masquerading or spoofing somebody else's layer 2 address. So although a normal computer, like an end station on a normal day, is going to use the burned in layer 2 address by default, with the correct software or the correct application running, a device doesn't necessarily need to use its own layer 2 burned in address. And in many attack situations, the attacker will not be using that default burned in address at layer 2. So out of these 5 assessment questions, how did you do? Did you get 3 out of 5, 4 out of 5, or all 5 out of 5? If you need to go back to that nugget and review it for any pieces that you may have missed, or if you want to use the online documentation, I would encourage you right now, while the concept is fresh, dig in, make sure you get your questions answered, and then when you're ready, we can continue on with the next video.